Welcome to a journey through our celestial neighborhood. Today we're going to deep dive into the intricate dance between the sun, earth, and the moon, and then venture further into the fascinating phenomenon of planetary seasons. Forget textbooks for a moment. Let's experience this cosmic ballet together. Our journey begins with the moon, that ever present companion, silently orbiting our Earth. What secrets does its journey hold? As the moon orbits Earth, the amount of sunlight we see reflected from its surface changes. Because the moon doesn't emit its own light, it reflects the sun's. So imagine you're standing on Earth. When the moon is between the sun and Earth, you see nothing. That's the new moon. And as the moon moves, we begin to see a sliver, a crescent, then a half moon or a quarter moon, and finally the full moon, where the entire face is illuminated. Now here's the fun part, predicting the moon rise and moon set. The phase dictates when the moon is visible in the sky. A full moon rises around sunset and sets around sunrise. A new moon is up during the day. A first quarter moon rises around noon and sets around midnight, and so on. But the moon's orbit isn't just about phases. Sometimes it aligns perfectly with the sun and earth, creating spectacular events, eclipses. A solar eclipse happens when the moon passes between the sun and the earth, casting a shadow on earth. But because the moon's orbit is tilted, its distance from Earth varies, so these alignments are very rare. A lunar eclipse occurs when Earth passes between the sun and moon, casting its shadow on the moon. This can only happen during a full moon. Notice the reddish hue? That's from the sunlight refracting through Earth's atmosphere. The moon's gravitational pull doesn't just affect light, it affects our water. Let's talk about tides. The moon's gravity pulls the water on the other side of the earth closest to it, creating a high tide. On the opposite side, inertia creates another tide. Low tides occur in between. The sun also contributes, but its effect is smaller. When the sun, earth, and moon align, during new and full moons, we get extra high tides, called spring tides. When they form a right angle, during quarter moons, we get weaker neap tides. Now let's move beyond our immediate neighborhood and explore the cause of planetary seasons. What makes Earth unique? Its axial tilt. This tilt, about 23.5 degrees, is the key to our seasons. Without this tilt, we'd have none. Each hemisphere would receive the same amount of sunlight year-round, but because of the tilt, as Earth orbits, each hemisphere leans towards or away from the sun. At the equator, the length of the day and night remain constant, but as you move towards the poles, the differences become extreme. During summer, the pole tilted towards the sun experiences 24-hour daylight. During winter, it's 24-hour darkness. The angle of sunlight, or the angle of incidence, plays a crucial role. When sunlight hits Earth at a direct angle, it's concentrated, delivering more energy, causing warmer temperatures. When it hits at a longer angle, it's spread out, delivering less energy and causing cooler temperatures. Finally, let's talk about solstices and equinoxes. These are key markers in Earth's journey around the sun. Solstices mark the points wherein a hemisphere is at its maximum tilt towards or away from the sun. Equinoxes mark the points where neither hemisphere is tilted towards or away from the sun, resulting in equal day and night. We've explored the moon's phases, eclipses, tides, and even planetary seasons. Remember, the universe is a dynamic, interconnected system. Understanding these interactions helps us appreciate the beauty and complexity of our place within it. Uncover the universe's secrets with She Explores the Cosmos. Like and subscribe to join the journey.